Hello friends, I am Samir and I welcome you all to your own YouTube channel Aryabhatta. Friends, today our topic of discussion is finding the inverse of a square matrix by matrix inverse formula. So, here in this video we are going to find out the inverse of a matrix, inverse of a square matrix by matrix inverse formula. So, before moving for that part, before moving for that formula, first of all let us take a square matrix of order n. So, we know that if you multiply a matrix with its adjoint or the adjoint of the matrix with the matrix, they both are equal and they both equals to a scalar matrix of the same order where the diagonal element is equal to the determinant value of the matrix if the matrix is non-singular. But if the matrix is singular, if its determinant value is 0, then the product of the matrix with its adjoint results in a 0 matrix of the same order. So, this formula or this definition of adjoint of a matrix we are going to use to create our formula of inverse of a matrix. That formula let us discuss through this theorem. Let A be a square matrix, then A inverse exists if A is non-singular and the inverse is given by A inverse is equals to 1 by determinant of the matrix A into adjoint of the matrix A. So, friends, the formula of getting the inverse of a square matrix is very simple. You have to just multiply the reciprocal of the determinant of the matrix with its adjoint matrix. Simple. You have to find out the adjoint of the matrix and with that we have to multiply the reciprocal of the determinant of the matrix. Now, friends, why actually I told you that the inverse formula of the matrix depends on the previous formula here above, that is the product of the matrix A with its adjoint. As you know already or you have already noticed in the theorem that the inverse exists if the matrix is non-singular, and this is the required and necessary conditions to find the inverse of the matrix. The necessary condition is it should be non-singular. The matrix is non-singular if its determinant value is not 0. If the matrix determinant value is not 0, then the product of the matrix with its adjoint is equals to the determinant of the matrix into the same order identity matrix. Now, the definition of inverse of a matrix is that if you are multiplying the matrix with its inverse, we used to get the same order identity matrix. So, say I am multiplying A with its own adjoint and I am getting this first value for the non-singular matrix system, that is the determinant of A into identity matrix of same order. Here I n identity matrix is a matrix, while determinant of this matrix is a scalar, it is a number. So, I can cancel this determinant value by dividing it on both sides, as it is a number only. So, if I divide determinant of A with the left hand side, then product of the matrix A with its adjoint divided by determinant of A will result in identity matrix of order n. So, if I am multiplying matrix A with the adjoint of A by its determinant, which is again a matrix, and it results in the identity matrix, that means adjoint of A by determinant of A is nothing but the inverse matrix of the matrix A, because their product is giving you the identity matrix, and that we have proved here. As you can see, the product of A with adjoint of A is equals to adjoint of A into product of A. This is not usually we have writing, this is a very important conditions, that they must be, first of all the product must be commutative, then the product is equals to or should be equals to the determinant of A into the identity matrix. As the determinant of A is a scalar, it is a number, it is a non-zero number. So, we can divide on all the three expressions. So, in this way we will keep A always separated from the others. So, A into adjoint of A by determinant of A is equals to adjoint of A by determinant of A is equals to I, the identity matrix. As the product of a matrix with another matrix which is commutatively equal, and that also result to an identity matrix, that means these two matrices A and adjoint of A by determinant of A, these two matrices they are inverse of each other. That means adjoint of A by determinant of A is the inverse of A. So, proved. So, the formula is very simple. So, this is the formula only to find out the inverse by matrix inverse formula. So, to find the inverse of a non-singular matrix, we have to first of all find out the adjoint of that matrix and the determinant of that matrix, and we will multiply the reciprocal of the determinant of the matrix with the adjoint of the matrix. But before starting or calculating the inverse, first of all we have to find out the determinant of the matrix, and we have to check that whether it is singular or non-singular. If it is singular, then the inverse will not exist, but if it is non-singular, if the determinant value is not 0, then we can go for the inverse of the matrix, because it will exist there. Okay friends, so let us discuss this one through one example. The question is to find the inverse of this 3 by 3 order square matrix using matrix inverse formula. So, for that, first of all name this matrix, say A is the name of this matrix. So, before moving for the adjoints and everything, first of all we have to find out the determinant of that matrix. So, the determinant of this matrix A I have calculated, and it is minus 2. So, it is minus 2. So, moreover it is not equals to 0, minus 2 is not equals to 0. That means, the determinant of A is not equals to 0, that means A is a non-singular matrix. If A is a non-singular matrix, then its inverse matrix A inverse exists. That means, we can now proceed further to calculate the inverse. So, for that we need cofactors, because adjoint is made up of cofactors. So, the cofactors of the elements of the determinant of the matrix A are C11, and you can calculate the cofactors as we have discussed this before, one by one. See, I have calculated all the cofactors. Then we will get C of A, as I already told you in my previous videos, that C of A I am representing as the cofactor matrix of A. That means, I am replacing all the elements by their cofactors in its own position, and by that I am getting a complete matrix of only cofactors of the elements of that matrix, and that I am naming as C of A, cofactor matrix of the obtained from the matrix A. So, you write the cofactors in that the place of the elements, put the values there, and now we have got obtained the cofactor matrix of A. Now, the adjoint of A is equals to the transpose of the cofactor matrix of A. So, find out the transpose of C of A. Again, let me tell you that transpose means changing rows into columns or columns into rows respectively. So, first row you make first column, second row you make second column, and third row you make third column. So, in that way you have obtained the adjoint. Now, the inverse, A inverse formula is very simple. It is 1 by determinant of A into adjoint of A. Determinant of A is a number, adjoint of A is a matrix. So, it is 1 by minus 2 adjoint of A, that is take the minus to the numerator positions to the numerator. So, it will become minus 1 by 2. So, the answer is minus 1 by 2 into the matrix, that is adjoint of A. Now, you can keep the minus 1 by 2 outside, or if you want you can multiply it inside. And let me tell you, if you are multiplying a number with a matrix, then you have to multiply that number with each and every element of that matrix. So, in that way you are getting the inverse of this matrix. So, friends, finding the inverse of a matrix is very simple by this formula, inverse formula. I have a shortcut formula to find out the inverse of a second order square matrix. Let us discuss that. So, the direct method to find the inverse of a second order square matrix. Let A be a second order square matrix where the elements are A, B, C, D row wise. Now, the inverse formula is 1 by its determinant. The determinant value is A into D minus B into C. So, 1 by the determinant of A, and this matrix is nothing but the adjoint of the matrix A. You can obtain it by your calculations. So, to remember it quickly, let me tell you that there are two diagonals, left diagonal and right diagonals. Left diagonal elements, you interchange the elements, take D in place of A and A in place of D, and right diagonal elements you do not change the position, but only change the sign of the elements. B becomes minus B and C becomes minus C. So, remember friends, the formula is very simple for second order square matrix. What you have to do? You have to first of all multiply 1 by AD minus BC, the subtraction of the cross products of the elements. With that, left diagonal or main diagonal elements you interchange, and right diagonal elements you only change the sign, and this is the formula for easily getting the inverse of a second order square matrix. Let us find out through one example here. Find the inverse of this second order square matrix where the elements are 1, 2, 3, 1 row wise. First of all, let us name this matrix as A. Here A inverse is equals to 1 by 1 into 1 minus 3 into 2 multiplied with the matrix. I told you left diagonal elements will interchange. Here 1 and 1 if will interchange as they are both same. So, no change will happen, and right diagonal elements sign I will change. Now, this positive 2 and 3 becomes negative, minus, it becomes minus 2 and minus 3. So, now you can calculate and you can get the inverse in this way. So, finding the inverse of a matrix by the inverse formula is very easy. Hope you understand this method and you will apply whenever it is required. Thanks for watching.